Now, the opposite operation to differentiation, anti-differentiation, is integration. And we were looking at the integration of sine and cosine. Now, since f of x equals sine x, f dash x equals cos x, then integrating cos x takes us back to sine x. Now remember, for the indefinite integral, integrating cos x, it's sine x plus c. If we have f of x equals negative cos x, f dashed x would be sine x. So integrating sine x takes us back to negative cos x. And because it's an indefinite integral, it's plus c. Now we have in the sheet some examples on integration, but we're going to look through a couple of problems. Let's look at question 3. If you were asked to integrate cos x, lower limit 0 and upper limit pi, and show the area in a sketch. Let's do the integration first. This is not an indefinite integral, this is a definite integral. So if we're integrating cos x first of all, that would be sine x. Now remember the format, integrating sine x from 0 to pi. Upper limit is pi, so that would be sine pi minus sine 0. Sine of pi is 0 and sine of 0 is 0. So the whole thing would result in 0. Now show the area in a sketch. That's the cosine graph, and that's why you're getting 0 there. Remember, we looked at this type of example in class 2. The area above the graph and the area below the graph are identical, so they're cancelling one another out. That's why you're getting 0. If it's an equal area above and below, remember, if you had been asked to calculate the area enclosed, you would have to evaluate integrating cos x from 0 to pi by 2, and then from pi by 2 to pi. Integrating from pi by 2 to pi cos x, you would get a negative, but then you ignore the negative sign. That's just indicating that the area lies below the x-axis. Finding the area between two curves, this is a problem from your textbook, page 275, question 6b. And that's it there. They ask you to find the area, the shaded area, the area enclosed between these two curves. Now remember how we do that. It would be upper curve minus lower curve. Now the upper curve there is root 3 sine x. Lower curve is cos x. So root 3 sine x minus cos x. We're given the points of intersection, so we're integrating from pi by 6 to 7 pi by 6. So the area would be given by the integral given there. So let's do that. If we're asked to integrate that, integrating root 3 sine x would be negative 3 root cos x, integrate cos x, and we get sine x. So we've carried out our integration, and we are integrating. I see I've missed off the lower limit. It would be pi by 6 to 7 pi by 6. So we replace those. We replace our upper value, 7 pi by 6, negative root 3 times cos 7 pi over 6, minus sine 7 pi upon 6, minus our lower limit, pi by 6, we write that in. So we have that. Then we put in our values. Negative 3 times negative root 3 upon 2, we find our values there. Put that in. Let's do the calculations inside the bracket. 3 upon 2 plus a half minus negative 3 upon 2 minus a half. 2 minus minus 2 is 4. So this is incorporating skills. All that's new here is integrating sine and cosine. These two questions incorporated skills that we had done before, that the area between two curves, upper curve minus lower curve, integrating from your lower limit to your upper limit. Okay, thank you.